Calculating octagon roofs, our in-class example, it was a building 16 feet by 16 feet, and we had to determine basically, in the end, what we're looking to get is the line length of the common rafter and line length of the hip rafter. There's a few things we had to do before that, but basically we're trying to achieve that by getting to that point. So kind of going back to geometry class, level 1, the way you actually lay out a octagon is you start off by making a square to the distance from side to side that it's parallel. So in this case it's 16 feet by 16 feet, so that'd be your first step. From there you'd find diagonals, right? So you measure corner or draw a line corner to corner. That'll give you the center. And if you set your compass from here to here, you could then swing arcs, which then would establish that point, this point, come over here, swing an arc with half of the diagonal, would establish that point and that point, again swing arc, gives you those 2 points, and then lastly that point gives you these 2 points, which then gives you all your points on the octagon. Okay. From there we'd have the shape. We could then measure that kind of thing, but there is also some math that we could do there. So we talked about a little bit yesterday for C. Maybe we'll wait till we get there, but C, there's a few different options there how we can get that. So let's start by working through the math there. So A is basically half of the diagonal. So step 1 would be finding the full diagonal, right? So that's a right angle triangle there. We've got 16 there, we've got 16 there. So for A, the first thing I want to do is find the full diagonal. I go in 16 to the exponent of 2 plus 16 to the exponent of 2. Once I get the answer for that, I'll then divide it by 2. Okay? Pull out the calculator here. Square root, bracket 16 x squared plus 16 x squared. Close the bracket, press equals. We end up there with 22.627417 feet. That's the diagonal from here all the way to here. We only want half of that, right? A, half of that. So if we divide that by 2 right away, we'll have A. So that's 11.3137. It's probably far enough. I'll just write that down here, 11.3137 feet, which is equal to 11 foot 3 and 3/4. Okay. B is the distance from here to here, which is basically half of the building, right? So if that was our span, we're basically getting the run, which ends up being the run of the common rafter. That's exactly where the common rafters would sit. This is where a hip rafter would sit on an octagon. So B is basically the run of the common rafter, which is half of 16 feet, which is 8 feet. So maybe let's put in brackets there. That's the run of the common rafter, which we're going to ask for right down here. Okay. C is the distance across the bottom there. So probably the fastest way to get that, without knowing any kind of tricks there, is working off of the corner here. So we looked at that yesterday in class. So we know the distance from there to there right now. We also know the distance from here to here as being 8 feet. That's probably the fastest way, right? So if we took the half of the diagonal minus the run of the common rafter, that will give us what we can call here x. So if that's x, and this is a 45 degree, and that's a 45 degree, that means this here is also x, and that would mean that that's also x. So once we know what x is, if we go x times 2, that'll give us basically c. Okay? So to get x, what I'm calling x, we're going to basically go A minus B. So A is 11.3137. Probably going to redo this in inches in a second here just to make sure we have good accuracy. With feet, we're not always with the best accuracy, right? Because we're rounding. I rounded that a little bit. So we'll just keep on going here, and we'll just see the difference there to kind of see the importance of maybe doing the math in inches. Okay. So if I go 11 3.3137 minus 8 feet, we end up with 3.3137 feet, which is basically 3 foot 3 and 3/4. Right, so that's one side of it. So we'd have to multiply that number there by 2 to get C, right? So for C, we have to go x times 2. So 3.3137 times 2. Which gives us 6.6274. So 6 foot 7 and a half. 8/16, which is a half. Okay, so I know that's a little bit off. So now I was going to redo the math quickly here by doing it in inches. I should have did it right away, but for accuracy, right, would have been better to do the square root of 192, which is 16 feet in inches, plus 192, the exponent of 2. I'm just trying to speed that up a little bit. So square root brackets 192 x squared plus 192 x squared, close the brackets, equals 271.529. We'll divide that by 2. That gives us 135.764502 inches. Okay, so a little more accurate there. I mean, if I keep all those decimals written down here as well as I keep it into my calculator, I can then just kind of come back over here. So what I'd have to do here is go, that number is the same as that number, 135.764502. I subtract 8 feet in inches is 96. So I left all the numbers there in my calculator without erasing them. Now I'll go minus 96. That gives me now 39, which is the same as that, 0.76450199. So I'm not going to erase anything on my calculator. Now what I have to do that number is I got to multiply it by 2. So I got to take 39.76450199 times it by 2. That gives me 79.529. I'm going to round it there just for purposes, because I got 2 zeros there. But then I'll put that in fraction form right away while I have all the accuracy there. So minus the 79 times by 16. So there it is there, 79 and a half. So that's basically 6 foot. There's 2, 7 and a half. It's the same number. It's the exact same number there. Okay. I thought it would be off, but I guess I kept enough decimals there to kind of make it work. So 6 foot 7 and a half. There's a little trick that I also mentioned yesterday. So if you want to get C, it's actually coming from the geometry book that we typically use with the apprentices there in level 1. But if you want to find the side of an octagon, you take the span and multiply by 0.4142. Right, so if we, in our case, it's 16 feet times 0.4142. It only works with octagons, but if we go 16 times 0.4142, we end up with 6.6272 feet, which is 6 foot 7 and a half. Okay, so that magical number there gives us basically the same answer, but a lot faster. Okay, so either way works, right? In the end, we want to know what C is. So C is basically 6 foot 7 and a half, which is 79 and a half, if we're going to use that for any other kind of math along the way. Okay. D now. D is basically the run of the hip rafter. Right. So if we know it this is 8 feet, and we know what half of C is, which we do, which we were calling x, okay? So we then use that number and that number to solve for the hypotenuse. So maybe just a quick little drawing of that right here. So we know that that there is 96 inches. We know that half of x is 39.7645. Let's say we'll cut off at the 0 there. So then I want to have to find the square root of that, which is going to be d here. I have to go to the square root of those numbers. So 96 to the exponent of 2 plus 39.7645 to the exponent of 2, brackets, and then square root button. Oops. 39.7645. X squared, brackets, equals 103.909605 inches. Okay? So I'm going to write that down in fraction form on that line there. I have it here in decimal form. So I'll go minus 103, left with the fraction, times that by 16. So it gives me 14/16, but that makes me bump it up to 15/16. So 103 and 15/16 would be the base of that. But we have that in inches there as well, okay? So run of the common now. So now that we have A, B, C, and D completed, basically all the important numbers on that piece of paper, the next step is just trying to put them into place. So now we're told that we're basically building a roof. It's a 712 roof. What is the run of the common? So the common rafters basically go here, right? They hit the flat part. Common rafters hit the flat part. So that's a common rafter right there, which is basically B. So the run of the common rafter is basically B, which is equal to 8 feet. Rise of the roof. So we could determine that by the same way we would on any other roof. If we know basically the run of the common rafter, we take the run and we multiply by unit rise. So if we go run times unit rise, so in this case there's 8 feet of run, therefore there's 8 triangles, times 7 inches equals 56 inches as a rise for that roof. The LLCR now, we could do that a couple different ways. We just basically solved the run and the rise here. So the hypotenuse is what we're looking for right now. So we could do that. Or we could also use the old-fashioned run times UCR. Something that we use quite often with all our buildings, right? So that'll work with an octagon. So we know the run of the rafter is 8 triangles. We know the UCR of a 712 is 13.89. So line 1 on the framing square under the 7. And that will give us our answer there, right? So if we go 8 times 13.89, we get 111.12. So 111 and 2/16, which is 1/8. Okay? So the other way we could have did that, like I said, was just solving the triangle. We know that this here, distance here, was 96. We know that this distance here we just figured out to be 56. What we're asked to determine was the LLCR, and that's what that is right there. So we could have used Pythagorean theorem. Let's just do it quickly without writing anything down. So I'd go square root, brackets, 96x squared plus 56x squared, close the brackets, press equals. They're just slightly off. Probably more accurate, because here the 13.89 is probably rounded. You see here it's not rounded at all. So if we subtract the 111 there, multiplied by 16, it's given the same answer though, 2/16, which is an 8. Okay? Run of the hip rafter, which we have right here, right? D is the run of the hip rafter, so D, and D is equal to 103 and 15/16. So just a matter of realizing that that's what it is. That's where the hip rafter is going to lie. And the last thing we have to do is basically determine LLHR. So we can almost do the same thing that we did there, right? The rise is still going to be 56 for both those rafters. Now that's LLHR, but the run of the hip is 103.9096 right up here, right? 505, I think. I guess we have no other choice. We have to do it that way, right? LLHR, so there's no number that we could use there. We could figure out a UHR for a octagon, right? So a hip rafter for a normal hip roof, this number down here is 17, but for an octagon, that's 13. So that would be 7. So we could try to figure out what that is, and then multiply it by the 8 feet there, but we've gone this far. Let's kind of solve this one here. Okay, so let's forget about that. It's not really necessary. It's important to know that when you lay out the hip rafter, you lay it out to 7 and 13. Okay, maybe I'll explain that in a minute why. Common rafter, you lay out 7, 12. Hip rafter for an octagon, it's 7, 13. Okay? So if we were to finish this off here, we're going to find Pythagorean theorem there using those two numbers, 56 to the exponent of 2 plus 103.9096505 to the exponent of 2. I'm going to put them all in there. It's not any really longer. Square root brackets 56 x squared plus 103.9096505 x squared, close the brackets, press equals. We end up there with 118.0390461. So 118 here. So minus 118 times 16, that gives us 1/16. Okay, makes us round to 1/16. So that would be the length of that hip rafter. Okay, because of Pythagorean theorem, using these two numbers, there it is. So the reason why the 13 happens is because this corner right here, if I were to draw a line across here, that's basically the corner of a hip rafter, right? That's the hip rafter run right there. If we were to kind of imagine that all the way to this point. So if this was 12, that would be 12, that would be 17. So these two angles here, when we basically divide them, so that's a 45-degree angle. So we come out of that corner with our octagon, which that angle there should be 22.5 degrees. We then hit this location, and what that ends up giving us is 5 there. This is 5, this is 12, this is 13. When we look at, I changed that number there to 24. Right? I'm just kind of drawing on that. Everything is based off of that one corner there, where this is normally 12, 12, 12, 12. Right? We usually have it on the other side here as well. That's the run of the hip. That's the run of a common. That's now the run of the hip rafter for an octagon. So it's basically all coming out of that same corner. But we come down with, if that's a 45, we split it in two. We have 22.5 here, 22.5 here. As that line shoots down to the bottom, it hits here. That equals 5 exactly. That's 12, and that's 13. So if we look at this 0.4142, where does that come from? It's a little slightly off, 512. But if I go 5 divided by 12, it gets me pretty close to that. Right? So if I go 5 divided by 12, whoops, 5 divided by 12, I get 0.416. Just slightly off. This is more accurate. This is close. So it kind of all gets linked together there. Okay. So if I was going to cut a common rafter, I set my framing square to a, in this case, a 712, and I would cut the length at 111 and 1/8. If I'm going to cut the hip rafter for this building, I'd actually cut it at 118 and 1/16. Framing square would be set to 7 and 13. Whenever you go to build an octagon, you actually put all your hips in first. So all your hips get installed first. And what it ends up actually doing is creates a nice nice shape at the top, basically, right? So if you have your octagon there, just a quick little sketch here. If we have our octagon all these hips get installed first. So they actually come in and tie into the middle with thickness, right? So there's thickness there. And then you put that one on. So that one goes first, that one would go second. And then you do the 90 degrees to it. That would come in 90 degrees, that would come in 90 degrees from the hips. Then you could throw these in. That's going to now be, that's a 90-degree corner. So it'd be the same kind of a cut that we'd have on a hip rafter for a normal hip roof. Same thing over here. A little bit of a V there. Same thing here. So some people cut a block to go in the middle. That's another option. Every time I do an octagon, I do this here. I find it looks nice and clean at the top there whenever it's done. But you basically have the two first pieces come through 90. There's no reduction. I know normally we have to shorten for a ridge. In this case here, these two do not have to be shortened for a ridge. These two, you reduce it by half the thickness of this stock. So more than likely 3/4. And then these two and these two would have to be shortened by the 1/16. That would be 3/4 because that's 3/4. So that would be 1/16. So these are all hip rafters, which was 1/18 and whatever it was there. 1/18 and 1/16 would be the length from the very top of the roof, so the very center of the roof to the bird's mouth is what we just determined. And then that would give us right to that point right there. And that rafter would continue to a tail, which again would have to have some cuts at the end there. And those cuts at the end would basically be 22.5s. Okay, 22.5 here, 22.5 here. That would then continue to there, where there'd again be a 22.5, 22.5. Your fascia board, when I got it installed on the front of that, would be slightly mitered there. So that miter there is basically a 22.5 on either side. Right? Why? Because they're 45-degree angles, right? The way they kind of determine that angle is because if we shot that line through here, let's do one more here. So if I continue that line through, that's the 45. Right, so if you went from here, that'd be 135 degrees to that point. So if that's your pivot point, that's 45. If you went from here and started going around, work back to that point, there'd be 135 degrees here, 45 degrees left over. So we basically divide that by 2, and that gives us our miter angles here. Okay. So I think that's probably as far as we need to go there with this. The next step would be down in the shop, building it, putting it into play, going over a little bit more on those layout things. The biggest thing for me, like I said, is getting the math done. Once we got the math done, knowing what we set the framing square to, right? So we have the LLCR, framing square set to 712. We have the LLHR, framing square set to 713. Magical number there, 713.